Okay, trendsetters, so we're doing polynomial problem solving and we're going to use technology to help us. In the future, somewhat further down the future, you'll learn calculus and you'll have even more advanced mathematics to do such a question. But at this stage we're using technology to support us, especially in part B. So what we got is a square sheet of tin. You can see it there, it's 12 by 12. And we're going to cut 4 equal squares out of the corners. You can see that. You might have seen such a scenario before. And the sides are folded up to form an open rectangular tray or box. Okay, so basically they'll fold along here, and that will fold up. Imagine that folding upwards, and here that side will fold up, and those two sides will fold up, and you'll have like a tray or a box. And the height of the tray or the box, or the depth of it, will be equal to x. X is a variable. So the values of x we have to find, which make the volume equal to 100 cubic centimeters. So we're thinking, predict what might we use, make connections to our background knowledge, and basically volume. So you're looking at the volume. What might happen here? Background knowledge, volume of what sort of shape? Well, it's three-dimensional shape. It's a rectangular prism. So volume of a rectangular prism, right? And so we need to get a formula happening for that. So formula, we basically need to find volume is length by width by height. But of course we don't have such a thing exactly like that, do we? We have x, and we have 12, and we have 12. Alright, well, if that's folded up, maybe if we clarify it by drawing the diagram for it, you might have something like that. That clarifies things a little bit, doesn't it? And so on, and we've got there, and the rest of it's sort of hidden. And alright, so what have we got? We've got that and that. They're the same because it's 12. Well, it's based on 12. Maybe it's not 12. See, we've folded up the sides, and they're x, aren't they? So the height or the depth is x. That's not 12 anymore. Let's have another look at the diagram. When we fold it, we don't have 12. If that's the base, that's the length of the bottom, and that's the width of the bottom. That's less than 12 now, because we've robbed it of that there and there. We've robbed it of x and another x, so we've robbed it of 2x. So we have to find that we've got, instead of length, we've got 12 minus 2x. And the width's the same, because that's what we just noticed about it. So it's also 12 minus 2x, and the height is x. Alright, so basically let's get in and solve that, or simplify that. We've got something we've got to use some algebra on. So what we're getting to now, we've clarified, we've got an expression. Let's simplify the expression. So it's part of the solving process. So simplify what we saw just above, and that was v equals 12 minus 2x, 12 minus 2x by x. So you got basically two things the same. You got a minus b all squared. It's 12 minus 2x all squared, so we've got a squared minus 2ab plus b squared. So 12 minus 2x all squared will be 144 minus 48x plus 4x squared. Okay, so that'll be 144 minus 48 x plus 4x squared. Okay, so just putting that there so you can see it a bit better, because I've got a bit of a busy background on this. That's my fault for trying to be a little bit fancy and use a problem-solving process, which you should have. Yes, have some sort of process. But we've got what we've got here is another x times on the end. So we've got all of that times x. So just give myself a bit more room. So that would be 144x minus 48x squared plus 4x cubed is an expression for volume. Now at this stage, maybe we don't know whether we want it in expanded form, that's a cubic, or maybe if we want it in a factorized form, which means we head back to what we had above there. So factorized form, we go back up to this stage back up here. Factorized form, well, the best way to write that would be 12 minus 2x, and that's squared because there's two lots of it, isn't there? And there's a factor of x there as well too, so I'm going to stick him on the front. Okay, so we've got x outside of 12 minus 2x all squared. Now, what if that equals 100? Because if we go back to the question, you see part A there. What are the values of x that make that volume equal to 100? So we say, but in this case, v equals 100. So that means we've got 100 equals x outside of 12 minus 2x squared. Or in that expanded form that we had just above there. Alright, so I think I'm going to change to black now because it's getting a little bit hard down here to see that green. So in other words, if we go back up to that expanded form, 100 equals 144x minus 48x squared plus 4x cubed. And to solve that, we could write 4x cubed minus 48x squared, 48x squared plus 144x minus 100 equals 0. So every term can be divided by 4, so that would be x cubed minus 12x squared plus 36x minus 25 equals 0. Now it depends on, if the question says you must use by hand methods, you would need to use some of the methods we've looked at in our unit of work to basically find factors and solve the cubics. If you can use technology, that's probably the easier way to go. So we might just assume here that we're going to use technology. We need to solve that. So let's get our technology. So here we go, got the graph plotted, and we need to solve that. And basically we can use analyze graph, and let's look at the zeros. 1 there, 1 0, repeat, analyze graph, 0, 1 there, and analyze graph, 0, 1 there. Alright, just going to raise them up just so you can see. Nice and easy. Gives us 3 values. Now we've got to check the validity of these values. Okay, are they all valid? Well, what has this found a value for x? Alright, which is the little square out the corner. So 3.21, yep, we can make x that big. Now remember, x is cut off both sides. What's the biggest value we can make x for that box? Well, it's 6, isn't it? Because if you think back to what we were doing, the box, go back to it, if we made x any bigger than 6, that would mean that each part of the little squares would actually get to the midpoint, so it's got to be less than 6, and one of those values is not. It's 7.79, so even though that's mathematically right, we have to reject that. Alright, so there's our two answers, 1 and 3.21. Last thing we've got to do is find the maximum volume. So we need to go back to our expression for volume, back to our equation there, and doesn't matter which version, you just need to plot that. So I'm going to choose the polynomial version, or I might choose just to show the factorized one works, I'm going to choose the factorized version there. So I'm just going to grab that and put that here, paste that in. Will it paste into this file, I wonder? No, it won't, but still I got the graph in there anyway, so I plotted the graph, and it's the blue one here. We want to find the maximum value of that. Now remember, x can't be over 6, so I've put my settings for x to finish at 6, so if there are any other maximums we ignore them, and we can simply go analyze graph, and we want to find the maximum, and this graph, lower boundary, upper boundary, and 100. So when x is 2, we get 128 for V, for volume. So 128 is the greatest volume.